In this video, we're going to discuss how to find standard deviation and variance of a discrete probability distribution function. Okay, so here is the probability distribution function. It represents the number of cavities of adults aged 30 years old in the United States. Okay, so that's what X stands for. And so the P of X would be the probability for each of these number of cavities, right? So the probability that someone in the population, which is the population is adults aged 30 years old in the United States, probability that they have, say, 2 cavities is 0.33, right? The probability that someone in this population has 5 cavities is 0.07, right? So we could read this. This is representing the population. That's a key, and it's a very important thing to understand, that this is representing the population. This isn't information coming from a sample, rather this is information representing the population. All right, so now let's go ahead and find the standard deviation and variance for the number of cavities in this population. Okay, so first I'm going to start by giving you the equation to calculate the standard deviation and variance. I'll go ahead and write it down here. So the equation for standard deviation, you remember we use this Greek letter sigma to represent standard deviation. This is going to be the square root of the sum x minus mu. Okay, remember what mu is. Mu is the population mean times p of x, the probability of x. So you take the square differences from the mean and you multiply that by the probability of the value of x, right? So you it's like a weighted sum, right? A weighted average, weighted by the probability of observing that value of x. And then you take the square root to basically get rid of the square. Sigma squared, this is the variance, it's just the square of whatever the standard deviation is. So it's just the same equation here, just without the square root sign. Okay, so this is standard deviation, and this is variance. All right, so let's go ahead and calculate these guys. To calculate them, I like to use a table. Okay, so first thing I'm going to calculate is x minus mu. So the difference from the mean. Okay, so I'm going to calculate the difference minus the difference from the mean. All right, let me go ahead and fill out this table. The second thing I'm going to calculate, so the second row that I'm going to add is the difference from the mean squared, right? So I'm basically going to square the previous row. So that'll tell me this square here, difference squared. Then last row I'm going to calculate is the difference squared times p of x. Right? So the difference squared times p of x. That's what we see here. So then you're going to sum up this last row here. You're going to sum up this last row. Right? The sum of this row will be this piece of information, will be that piece of information inside of the square root. So you'll take the square root of it, and then you'll know what sigma equals. All right, so let's start filling out this table. Now, to fill out this table, you need to know what mu is. In the previous video, we calculated mu. So in the previous video, we calculated mu to be 2.12. Mu, the population mean, okay? So we calculate the population mean to be 2.12. Let's go ahead and fill out this first row here. We have 0 minus 2.12. That's going to be negative 2.12. I'm taking the value of x and I'm subtracting off mu. So 1 minus mu, 1.12. 2 minus mu, so 2 minus 2.12. That'll be negative 0.12. Okay, then 3 minus 2.12. that would be positive 0.88. 4 minus 2.12 would be positive 1.88. And then 5 minus 2.12, that will be 2.88. Okay, so now let's go ahead and square the previous row. So square negative 2.12 is 4.494. Square of 1.12 is 1.254. Square of 0.12, or when you square it, the negative sign goes away. Actually, this one should have had a negative sign. But it doesn't matter because the sign goes away when you square it anyway. Okay, so the square of negative 1.2 is 0.014. Then square of 0.88 is 0.774. Square of 1.88 is 3.534. And then the square of 2.88 is 8.294. Alright, so last step, take this previous row, alright, take that previous row and multiply it by the probability of x. Okay, so take 4.494 and multiply that by 0.12. So that'd be 0.539. Take 1.254 and multiply that by 0.21. That'd be 0.263. Take 0.014 and multiply that by 0.33. Okay. That would be 0.005. 0.139. 0.318 and 0.581. Okay, so if we sum up this last row, so we take 0.539 plus 0.263 plus 0.005, we add it up, what we'll get is the sum equals 1.85. Right? So that actually is the variance, right? The sum of the square difference from the population mean times the probability of x. This is the variance. So sigma equals sigma squared, variance, sigma squared equals 1.85. Okay, so this is the variance. All right. So now if I want to find the standard deviation, which usually we do, we want the standard deviation to make interpretations, right? This does not have a unit of cavities, right? 1.85 cavities, no, because it's the variance that the unit is squared, right? So I need to take the square root to get the unit back to just being cavities. So I take the square root of 1.85, which equals 1.36. So standard deviation is 1.36 cavities. Right, so 1.36 cavities. This is the standard deviation for this probability distribution function.